Some of the mathematical practices are to persevere. Many of my students, their goal is to get done and when they come in, and I really try to change that. So I want them to persevere in problems because there's what we ask them to do, we're not prescribing the exact steps to follow. So we want them to understand the problem and persevere in solving it.
Most of the work we were getting, I didn't understand. And like we were working in groups and stuff, but I wouldn't really like contribute, or I just wouldn't understand, so I just like follow what other people were saying. But now it's like with working together and stuff, I just kind of like put like an effort, I guess. I don't really know how to explain it, but it definitely helps like you analyze or understand, like try to like break down the questions and stuff.
I would say definitely problem solving and word problems. Usually I skip over word problems and go back and do them last, but this class has been focused mainly on word problems and problem solving situations. So now it's become a lot easier to do.
I'll probably like skip over and then go back or like ask for help, or if I just don't understand, I'll just like put something down.
And what do you do now?
I kind of just like work my way through it.
Yeah, one of my students at the beginning of the year was very resistant to this type of learning. And by this type of learning, what I mean by that is they didn't, when they asked a question, they wanted me to give them an answer, and they got very frustrated if I just answered a question within a question. By the end of the year, this student not only just mathematically is stronger, but when I ask for volunteers to read or to put things on the board or to show their work, they're the first one to volunteer.
It helped me in real life situations because it deals a lot with problem solving, and problem solving is pretty big. You're gonna need that everywhere you go.
I think that all the equations and the y equals mx plus b, I've gotten better at that, and all the words and all the definitions you need to have for that class, I've like got it down packed. Even to have like plan A and plan B and plan B to like see if this situation doesn't work, what other situation would, and if that one doesn't work, what other situation would, and just different ways to work and find ways to find your goal.
I want to say equations, but like the way that you would problem solve, the methods and routes, sometimes you can plug those into what you're doing and it can make what you're doing like a lot faster, like easier to reach your answer or what you need to find.
How to convince others that what you're doing is mathematically correct. And also listening to others and critiquing what they say.
It's helped me be more outspoken. It's helped me communicate better with other people in my group and bounce ideas off of one another.
One student in particular, I happen to have had that student for Algebra 2. And the person was, I would say, was a student who did not particularly like math, but really, I think, is good at math. Well, she actually was very responsive to this course. One of the things she grew in is being able to explain things. I can tell you that in the beginning, she would actually be very forceful with other males in the class when they were trying to say that things weren't right, and they would argue nicely, but she was very emphatic about standing her ground and explaining detail for detail how things worked.
To hear everybody's like thought process of how they get different answers, like someone might do one method and someone gets the same answer but it's completely different, and it's like you might understand one method and the other one's confusing. It's like, how did you get that? Like what? But that's also another cool thing, you hear different people's like way of thinking.
I remember we did the cancer cell M&M project. We basically took M&Ms and we would dump them out of a cup, and all the M&Ms that had the M on the top would represent a cancer cell. So they would multiply, so we add one more, and then we keep doing it more and more and more until we got our final result.
For many of the students that come to me, the technology that I use It's the first time they've ever used significant amounts of technology in their mathematics courses. Yes, they've been experienced to calculators, but I use computers, calculators, sensing devices, data gathering instruments. And so for many of them, it's almost like a science course.
We used the graphing calculators, and we did spreadsheets. And for me, I have not done a lot with spreadsheets in the math classroom. So that was a learning experience for me as well. And it seemed like the students really started getting into doing the spreadsheets towards the end of the year when we did the loan project. They just jumped right into doing spreadsheets for those. And then the other thing was doing the Google slides, doing the presentations, which they were pretty comfortable with that.
One of the things in the investigative part in this mathematics is I try to have students look for patterns.
I can calculate things really fast now. My brain works out things really, really quickly. I used to not be able to comprehend stuff as quickly, and now I look at numbers and I can add up things extremely fast, and it just really helped to do that.
I used to use a calculator for a lot of equations, a lot of addition, a lot of subtraction. Like, not like a simple division, but like long division or multiplication or radical equations. But it's kind of like second nature when I come here now, because it's like you've gotten into a habit of this being this, and so if that's like this from that, then you can only expect that. That makes sense.